Hey everyone, welcome back to the channel. Today, we are going to build something really exciting and super practical, an email spam classifier using Python and machine learning. Now, if you're completely new to the machine learning or data science, don't worry at all. I'm going to walk you through every single line of the code, explaining exactly what it does and why we need it. By the end of this video, you'll have built your very first machine learning model that can actually predict whether an email is spam or not. How cool is that, right? So let's jump right into Visual Studio Code and get started. All right, first thing first, let me show you the libraries we are going to import at the top of our script. I'll type these out and explain each one. So yeah, let me create Jupyter notebook file, or just name it new .ipynb. Make sure you have created your Conda environment. Let me select one. Yeah, here we go. Import the pandas. Import pandas SVD. And from Scikit-learn dot model selection import print split. So here we are importing the pandas as PD, and the pandas is like Excel for Python. It helps us work with data in tables, which we call data frames. We'll use these to load and look at our email data set. And you can see the line 2 from sklearn, which is the most popular machine learning library in Python. We are importing print split here. This function will help us split our data set into two parts, one for training our model and another one for testing for how well it works. Then go for from sklearn dot feature extraction dot text import count vectorizer. We are importing the count vectorizer. Now, here's the thing. The computer don't understand the words. They only understand the numbers. So the count vectorizer will convert our email text into the numbers that the machine learning model can understand. Think of it as a translator between human language and the computer language. And move to another part of the code from sklearn neighbors import multinomial NP. We are importing the multinomial NP, which stands for the multinomial naive Bayes. This is the actual machine learning algorithm you will use. Don't worry about the fancy name. It's just a simple and effective algorithm that works really well with the text classification problem like spam detection. With the final part from sklearn dot metrics import accuracy score and the classification report. But importing the accuracy score and classification report, this will help us measure how well our model is performing. Basically, how many emails is correctly identifies as spams or not spam. Now let's load our dataset. For this project, we are using a CB file that contains the email label as either spam or ham, where ham is just mean a normal or legitimate email. So you can download the dataset from the Kaggle. So just load the dataset. Here, is equal to pd dot read CSV. And copy the path and paste it right here. So what happened here? We are using the pandas read underscore CSV function to load our spam.csv file into a variable called df, which stands for the data frame. Let's take a quick look at what our data looks like. So I code print df.head The head function shows us the first 5 rows of our dataset. This is super helpful because we can see the structure. Typically, we will have one column with the label, either spam or ham, and another column with the actual email text or the message. Let's also check the shape of our dataset. So we'll just write print default shape. So yeah, this tells us how many rows and columns we have. For example, here you can mention the 3000 rows and 2 columns. That means we have 3K emails to work with, which is great for the training our model. Before we jump into building the model, let's understand our data better. So we have to check the column names, print columns, default column dot tourist. Yeah, this confirms we have 2 columns, email and label. Now let's see how many spam emails versus not spam emails we have. So we are going to check the distribution of spam versus not spam. You print in label distribution and printf of label dot value counts. Run this. When we run this, we will see that we have 2500 emails labeled as 0, which means not spam, and 500 emails labeled as 1, which means it's spam. This tells us our dataset is imbalanced. We have more legitimate emails than spammed email, which actually reflect real-world scenarios where most emails are spam. Let's also check if we have any missing data. So check for the missing values. Print checking for missing values and yeah, print df is null.sum. This shows us we have one missing email in our dataset. We need to handle this before training our model. So let's remove that row. Just drop any missing values. df is equal to df dot drop now. Print in dataset shape after dropping missing values. Let's run this. Yeah, now we have a clean dataset with 999 emails, and we are ready to move forward. Now we need to separate our data into 2 parts, features and target. So the variable x is equal to df email and y. Y is label. Let me explain this clearly. Think of x as the input. These are the email messages that our model will read and learn from. And y is the output. These are the labels telling us whether email is spam or not spam, which means the 1 or 2. The model will study the relation between the x and y. It will look at the word and patterns in the email, or which means the x, and learn which patterns typically appear in spam versus legitimate email, or the y. This separation is absolutely crucial because in machine learning, we always need to distinguish between what we are learning from and what we are trying to predict. Yeah. Next, we will split our data into training and testing sets. This tab explain x test, y train, y test. Zero train test spread. Here we have x and y, and the test size is 0, and the random seed is 42. So the random state. And I can write the print statement. Print training set size len of x train. Your testing set size len of x test. So this is a really important step. So let me explain it carefully. Firstly, you are taking 2,999 emails and splitting them into two groups. 80% of the email, about 2,399 emails, will be used for the training. And this is where our models learn what spams look like by studying the patterns in the email text. The remaining 20%, about 600 emails, will be set aside for texting. These are emails the model has never seen before, and we will use them to check if our model can correctly identify spam in new or unseen emails. And why do we do this? Well, if we train and test on the same data, it would be like giving the students the exact same questions on the test that they studied. It wouldn't tell us if truly learned the concept. By testing on new emails, we ensure our model actually learned to recognize the spam or memorize trained data. And here you can see the random state. It's 42. It's just a number that ensure we get the same split every time we run our code. You could use any number or 42. It's just a popular choice in the programming community. And remember, when I said the computer don't understand the words, well, now time to convert our email text into numbers using count vectorizer. So initialize the vectorizer. Vectorizer will count vectorizer. And x train vectorizer is equal to vectorizer dot fit transform x train. And the same for the x test. And print summary. Print number of unique words. Number of unique words, len of vectorizer, dot get features name out. So yeah, let me run this first. I'll explain it. You can see the number of unique words. Here it is. Firstly, we create a count vectorizer object. Here, this is our text to numbers converter. Then we use fit transform here on our training emails. What is this? Is magical. It first goes through all the training emails and creates a vocabulary of every unique words it finds. Then it converts each email into a list of numbers, which is representing how many times each word appears. For instance, if an email says, win free money, click here for free places. Let me show you. It's a sample. Win free money. Click here to claim your free places. Yeah. So the vectorizer might count free appears two times, and win appears one times, and the money appears one times, and so on. For the test data, we want to use transform, not fit transform. You can see that. This is crucial. We only want to use the vocabulary we learn from the train data. This prevents something called the data leakage, which would give us vastly good results. When we print the numbers of unique words, you'll see it, probably the several thousand words. That's our model's vocabulary. Here, let me upload this. Now comes the exciting part, training our machine learning model. So let me initialize the model. Model is equal to multinomial NB, and train the model. Model dot fit x train effect and y train. Then print it. Print Model training complete. Yeah, this is surprisingly simple. We create our multinomial name pairs model and store it in a variable called here the model. Then we train it using the fit function, passing in our vectorized training emails and their corresponding labels. What's happening behind the scenes during training? The model is learning which words appear more frequently in spam emails versus list made emails. It's calculating the probabilities, like if an email contains the word free three times and the word winner twice, there's an 85% of chance it's a spam. It does this for thousands of words combination, building a statistical understanding of what spam look. And just like that, in these few lines of code, we have trained a machine learning model that can now make prediction. Now let's see how well our model perform on email it has never seen before. So let's paste this widespread to the model predict x text vector and print the output. Yeah. Here we're asking our train model to predict the labels for our test emails. The predictions are stored in widespread. Now let's check how accurate our model is. We forgot to import another package, same with confession matrix, and run this and get back here. Now let's check how accurate our model is. Accuracy, accuracy score, weightage, and widespread, and print the accuracy. Can change this. Yeah. Now let's run this. You can see the accuracy 99.17%. The accuracy score function compare our model's prediction with the actual labels and tells us what percentage we got correct. We multiply by 100 to convert it to a percentage and format it to two decimal places. With this dataset, you'll typically see accurate around something like 99, which is really impressive for such a simple model. But accuracy alone doesn't tell the whole story. Let's look at more detailed report. Print it, print the classification report. Classification report. Yeah. So the classification report gives us the depot insight. It shows position, recall, and inference score for both spam and non-spam categories. And here the position tells us of all the emails we predicted as spam, how many were actually spam. The recall tells us of all the actual spam emails, how many did we correctly identify. And both metrics are important because we don't want to accidentally mark legitimate email as spam. That would be false positive. But we also want to catch as much spam as possible. Let's also look to the confession matrix. So print the confession matrix. Print in confession matrix. Yeah. The confession matrix shows us exactly where our model made mistakes. You can see the four numbers represent the true negative, which means the correctly identified, not spam, and the false positive, which is wrongly classified as spam, and the false negative, missed spam, and the true positive, which is correctly identified as spam. So finally, let's test our model with some custom emails to see it in action. Yeah, test the email, test email, test email one. And you can see, congratulations, you have won a 1,001 gift card. Click here to climb your prices. And test check this. Saves, remove the X in here. vector dot transform decimal and prediction one. Prediction one, model predict text vector one, and the print prediction just changes HTML one, and print prediction spam if prediction one is 0 is equal to 1 elsewhere not spam. Yeah, so we are creating the test email that sounds very spammy. It has words like congratulations, want, free, and click here now, which are typically spam indicators. We transform it using our vectorizer to convert the text into numbers, then ask our model to predict whether it's spam or not. When we run this, it should calculate identify it as spam. Is a prediction. Yeah. Let's try another one with a legitimate email. Test with another. Test email 2. Test email 2. Something like, hey, are we still meeting for lunch tomorrow? More at 1 p.m. Let me know. And run the test vector 2. Vector dot transform test email 2 and prediction 2. Yeah, the same thing. Just on this. This is a normal conversation email. Our model should not, the model should correctly identify it as not spam. You can see the correct prediction, not spam. You can experiment with different email text to see how your model performs. And there you have it. And there you have it. We have just built the complete machine learning spam classifier from scratch using your own dataset of 3,000 emails. Let's recap what we did. So yeah, we just loaded and export our dataset, split into the training and testing set, and converted emails text into numbers that computer can understand. And the trained naive-Bayes model evaluated its performance with impressive accuracy and tested it on custom emails. But the best part, this same approach can be applied to so many other text classification problems. The sentiment analysis on product review, categorizing customer support tickets, detecting hate speech, or even classifying news articles by topics. I hope this tutorial gave you confidence that machine learning isn't as scary as it seems. If you have any questions, drop them in the comment section below. Don't forget to give this video a thumbs up and subscribe for more beginner-friendly coding tutorial from ElevanceSkills. So, thank you so much for watching, and I'll see you in the next video. Happy coding and keep learning.